Welcome back, Paolo again. Today is a very intense day. There is actually a very interesting news. So first of all, for those who do not live in the United States, in this country, R&D is a serious thing, and lots of technological advances and also industrial revolution come from government investment. So I read an article that the DARPA, which is basically the most advanced branch of the US military research, is planning to invest $2 billion. Yeah, you have heard it correctly, $2 billion on advancing artificial intelligence. Now, before we go into the details, I want to explain to the public that does not know what DARPA is, what type of project they get involved in. So basically, DARPA stands for Defense Advanced Research Project. And what they really want to get into is enabling the next level of technologies, things that are not present today. And they are willing to risk all the money, just lose all of them, as long as they invest on something that is revolutionary and transformative. So just to make some example of things that they have invested in. I mean, you might have seen those planes that go at 6,000 kilometers per hour, and now they're working on planes that go even at faster speed than that. They have some of the most recent things they've worked on is, for example, the ladder, which was the technology on which the entire autonomous car movement is based. And before that, even before that, all the GPS technology was invented because they wanted to have the ability to communicate all over the planet for the military. So the technology was invented through DARPA, I think in the 60s or in the 70s, and then it became eventually, it went into the masses and became commercially available, but initially it was available only to the military. So with that said, now that you kind of have an idea, especially if you don't live in the United States or you've never been involved with really advanced technology and forefront technology, now that you have an idea what DARPA is, I'll tell you what they're going to invest in. So basically today, as of today, there are two huge limitations in what we call artificial intelligence, which for the most part is what's called narrow artificial intelligence, meaning it's a system that is able to accomplish a task that requires decision making at each moment, but it's really specialized in that task rather than in multiple tasks. Now, if you look at today things like, for example, Google Home or Google Voice, be honest, have you used it? See, if you really want to have a conversation with Google Voice, after, I would say, 30 seconds, you're already pissed. Like, it can only respond to some prepackaged expressions. And yes, it's very intelligent in telling you the latest news, in telling you the latest value of the stock price of a certain list of stocks that you have selected. But if you really start having a normal conversation as you had with a human being within 30 seconds, I can guarantee you that you're going to be completely pissed. And why is that? Because the math on which the systems are built is basically unable to basically recognize the context. Like Google Voice cannot, Google Home, for example, cannot really understand if you're switching context. Like if you're going from willing to talk about stocks to willing to talk about another topic, but in a different way. So they can only receive this very encoded initiation of a conversation, and then they have a very standardized way to do it. But as soon as you go outside of the standardized way, there is nothing to do. So it seems that DARPA wants to tackle this problem. Now, the problem I explained with the example of Google Home is actually present in every and each application of artificial intelligence. So as soon as the context changes or the context is not being predicted, So, for example, a typical example that people right now are mentioning is what's going to happen if, let's say, you have a car that is crossing, is driving onto a street, and there is a kid that is crossing the road, and then immediately after there is an old elderly that is crossing the road, and the car cannot stop what it should be doing, and so on and so forth. But basically, everything is not really predictable, or when the context changes, these systems usually tend to fail. And so DARPA is tackling this problem. I don't know the details. I will go and look into what type of research they're going to do for this. The second big problem is in the field of artificial intelligence or machine learning. It's a problem that the vast majority of consumers or people that are outside of the field that do not know about, but it's a really, really, really extremely problematic because it introduces an enormous cost. And this problem is that most of these systems have the ability to learn, but in order to learn, they need gigantic amount of data. And in order to improve that level at which they reach after the first sequence of learning, I was saying training, which is the type of word that we use in the Ergo. In order to improve, they need again even more data. But data per se is not the problem. The problem is that the data that they need to learn are data that need to be labeled. So it means there has to be some kind of human work, usually done by hundreds of people in various countries that really attach a label. So, for example, if you want to have a computer learning that a certain chimpanzee, you have to have people all over the world that takes 10,000 pictures of a banana and stick the word banana on a file next to the picture. And so that's extremely consuming. It's extremely consuming, time-consuming operation. It's costly, and it limits also the speed with which you can deploy new models to solve different type of problems, because effectively you have to go to this step which is known as training of the models, and it's nothing else than just teaching these models as if they were kids, but it's just the way you do it is with an enormous amount of information that really humans don't need that much information to learn. And what humans have is the ability to, once they've been trained on something, they can extend that ability. And so DARPA, the Defense Research Project, wants to go into eliminating this problem, or at least severely, significantly attenuating it. So both of the things are pretty much interesting because these are two huge limitations today with these systems. When it makes me smiling when I hear people talking about that the people jobs will go all in the garbage and so on and so forth. As a part of that might be true in certain type of industries like transportation, logistics, and so on, but to an extent, because these systems, as of today, they're very narrow specialized. They are very narrow specialized, and you cannot really let them, go and do things on their own, because there will come the moment in which the context switches, and there will come the moment in which they will face a situation that was not predicted, that was not part of the initial context that was set up, and in that particular situation they will not work well. And so they basically do not have the ability to learn from the stage where they are. So it's getting into the next level, learning into the next level alone, as a kid does, for example. That ability is still not there. It's very primordial, and it always requires human assistance. You cannot let them go. It's a humans have to come back and teach them again and again and again and again. And so that is the huge limitation. DARPA is trying to address these two limitations. I thought the article was very interesting. I'll certainly take a closer look at what actual research they're going to do and what technologies they're starting to invest, during this phase, usually the material that they do research on, it's of public, it's publicly disclosed. Only certain other type of projects become secret, but these are usually publicly disclosed, and the results disseminated, and that's the way with which then these inventions eventually find their way to viable commercial applications at a certain point in the future. Thank you so much. This is Paolo again from California. It's very late here. I say hello to everybody. If you are in other continents, probably now it's day, and so have a nice day. For those who are here in the United States, have a good night. Okay, bye bye.